Okay, so this is the last part of chapter 4, and then we will be moving on. So now we're going to talk about dilations. So dilations is when there's a scale factor, and the scale factor determines if your object or your shape is getting larger or smaller. So that scale factor will determine that, okay? So by definition, a dilation, so a dilation is a transformation in which a figure is enlarged or reduced with a respect to a fixed point called a center of dilation. So center of dilation. And a scale factor, which is represented by the letter K. So scale factor will always be K, which is the ratio of the lengths of the corresponding sides of the image and the pre-image. So this time we are going to keep the same shape, but this time it is no longer going to be the same size. So this is not a congruence transformation or a rigid motion. The angle measures will stay the same. So when your scale factor, or your K, when it is greater than 1, this is going to be an enlargement. And when your scale factor is somewhere between 0 and 1, meaning a fraction, not an improper fraction, but an actual fraction, this dilation is called a reduction. Okay, so bigger. So when K is greater than 1, it's bigger. When K is less than 1, it is smaller. All right. So find the scale factor of the dilation. Tell whether it is a reduction or an enlargement. So what we're going to do is we're going to compare two sides. So they're telling me that this whole thing right here is 4, and this piece right here is 2, which means this piece right here is also 2. So if I'm going to compare this piece from C to here to this piece to this piece, so this is 2 to 4. So you're always going to go new over old. How do you know which one is new though? Okay, the one that is new is always going to be your prime. So that is your new. This is your old. In other words, it's always going to be image over your pre-image. So new over old. So that means this reduces to a 1/2. Therefore, my scale factor is 1/2. Since K is less than 1, this is a reduction. So I went from being a large pyramid to a small pyramid. All right, so looking over here, I'm going to highlight. So my original starts at C and goes to P, and then the other one goes to P prime. So if I do new over old, so the new length is 25, the original length is 20. This will reduce to 5 over 4. Well, 5 over 4 is the same thing as 1 1/4, which makes this greater than 1. So my scale factor is 5 over 4, and this is an enlargement. All right. This next one says to graph the polygon and its image after a dilation centered at C with a scale factor of K. So there are rules on your formula chart for dilating. The best part about dilations is all you have to do is take every single number except for the center. You do not want to use the center. So my center of dilation is right here. But all you do is multiply every number by the scale factor. So for example, if we do, our scale factor is 1/5. So we're going to create a table. So we have our original, which is XY. And then our new points are going to be 1/5 X, 1/5 Y. So you're going to take and multiply all of these numbers by 1/5. So we've got P, Q, R, and S, and I'm going to scroll up just a tiny bit. All right, so P is at negative 10, 0. So if I multiply negative 10 by 1/5, that gives me negative 2, and 1/5 times 0 is still 0, and this is my P prime. The next point is Q, which is negative 5, 0. Well, negative 5 times 1/5 is negative 1, and negative 1/5 times 0 is still 0. This is my Q prime. R is at 0, 5. 1/5 times 0 is still 0. 1/5 times 5 is 1. So this is my R prime. And point S is located at negative 5, 5. 1/5 times negative 5 is negative 1. 1/5 times 5 is 1. This is my S prime. So I'm going to plot all of these points. So negative 10, 0, this is the original. Negative 5, 0 is here. 0, 5 is here. And negative 5, 5 is here. All right, I'm going to cheat and use my little line tool. All right, so there's my first figure. All right, so that is my P, oops, that's P, Q, R, and S. Then I'm going to graph this one, and I will use a different color. All right, so this is negative 2, 0, negative 1, 0, 0, 1, and negative 1, 1. So now this one, so this is P prime, Q prime, R prime, and S prime. This red figure is 1/5 or 5 times smaller than this one because my scale factor was 1/5, which meant a reduction, which meant it was getting smaller. Okay. All right, this one says, let me move this out of the way, it says to find the coordinates of the image of the polygon after a dilation centered at the center. So this is our center with a scale factor K. All right, so actually we'll call this Q just to, so my center is Q. So all you're going to do is multiply every one of your numbers by this negative 6. So you're going to multiply by negative 6. So times, 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 and times. So your rule for dilations, so your dilations is the scale factor times x, your scale factor times y, and that is your new. So negative 6 times 3 is 18. Negative 6 times 1 is negative 6. Negative 6 times negative 4 is 24. Negative 6 times negative 1 is 6. Negative 6 times negative 2 is 12. Negative 6 times negative 1 is 6. So this is your new figure. Notice it is 6 times bigger, but it also moved because of the negative sign. Okay? All right. This one says, a biology book shows the image of an insect that is 10 times its actual size. The image of the insect is 8 centimeters long. So think of new over old. Okay, remember this is your image over your pre-image. All right. It says the image of the insect is 8 centimeters long. What is the actual length? So what is the pre-image? All right, so new over old, because it says it's 10 times. So this reduces to 4/5 or 0.8 centimeters. So the actual length, okay, a biology book shows the image of an insect that is 10 times its actual size. So it's 10 times its actual size. So the actual size was 0.8. So new over old. All right, this one says to describe the similarity transformation that maps the pre-image to the image. So if you look at your original, so NLM, so we're going to look at our XY. So N is at 0, 2, 4, 6, so 0, 6. M is at 0, 4. And L is at 6, 6. All right, and then if we look at our X prime, Y prime, N prime is 4, 2. Let's see. Oh, okay. So this is at 4, 2. So N prime is at 4, 2. L prime is at 7, 2. Okay, this is not. Oh, okay. First of all, this is a double prime. I'm looking on the actual. Okay. If you look at this, this is a length of 2, and this is a length of 1. So what I'm going to do is just erase this because this is actually way easier than doing it this way. So I don't even know why I did that. Okay, so you're going to compare your sides. So NM is the length of 2. N prime, M prime has a length of 1. Well, since this is your new and this is your old, that would be 1/2. Therefore, your scale factor is 1/2. Okay, so describe the similarity transformation that maps the pre-image to the image. It is half the size, and you can double check 1, 2, 3, 4, 5, 6, 1, 2, 3. This one is half the size of this one. So the similarity transformation. All right. So if we shrunk it, so if I took this and said, okay, this is at 24606, half of that would be, and I'm going to do it in a different color. So half of this point would be 30, and this is 1, 2, 3, 4. Half of that point, half of 4 would be 2. Half of 6, 6 would be 3, 3. So then it would move here. And then we split it over. Okay, so what we did is we shrunk it, and then we said, okay, now let's take this and move it. 1, 2, 3, 4. So add 4 to the X, and then subtract 1 from the Y. So we did a dilation and then a translation. So we did a dilation and then a translation to get this figure to this one. So shrink and slide. All right, this lesson was super short, and I'm going to show you one more piece when you come to class. So I will see you guys next time. Bye.